Hi folks, so in this video we're going to talk about how we can find the domain of a relation. In this, well actually it will actually be a function, and you can see our objective up top here. So we've already taken a look at using graphs, and so in this video specifically we're going to figure out the domain from the equation here. So here's the function we're going to look at. Our function is f of x equals 6 divided by x minus 3. So let's start off just by evaluating our function here. Sorry, let me just make some space here. We'll probably want a bunch of space here. Okay, sorry about that. So let's first evaluate f of -3, f of 0, and f of 2. So again, all this really means is in this first one, we are throwing in an input of -3, so x equals -3, and then x equals 0, and then x equals 2. So let's see, f of -3, that's going to be, well, let's see, 6 divided by -3 minus 3. So that'll be, what, 6 divided by -6, which is -1. Likewise, f of 0 would be 6 divided by 0 minus 3. And I'm going to put parentheses. I always put parentheses around my input just so I know exactly what is happening. Not necessary in these two cases, but especially when you're dealing with, say, squaring a negative number, this will be really helpful. So let's see, that'll be 6 divided by -3, which is a -2, I believe. And then lastly, f of 2 is going to be 6 divided by 2 minus 3, which is 6 divided by -1, or -6. Alrighty, so let's now evaluate or find f of -3. So that just means replace x with -3. Sorry, this should be +3. That's a mistake. Alright, so let's find f of +3 here. So first off, you should again pause the video here and try it on your own and see what happens. I'm going to assume that you did that. So let's do it. F of 3 is equal to, well, turn that x into a 3 on the bottom. And what happens here? So I got 6 divided by 0. And we've seen this a couple of times now, definitely in class. But remember, this doesn't work because, well, if you pretend if we think of division as you have $6, and so you have this would be like your start amount. Think about what exactly division is, and we want to turn that into the number of piles, I'll call it. And I usually think about it in money because that just makes sense to me. If you start off with $6 and you're putting you're splitting up that $6 into 0 piles, the answer, right? The answer is the amount of money in each pile. And so the question is, if you start off with $6 and you're splitting it evenly among 0 piles, how much money is in each pile? But if there is no pile in the first place, you couldn't even answer the question because it just doesn't work out, right? I don't know how much money is in the pile because there is no pile. And so when we run into this like kind of philosophical dilemma, this is where we call it undefined. There is really no answer, or so you could call it, this is a case of like no solution. You call it undefined. And so what happens here? Well, and we've seen examples of this where once you plug in, so if I plug in x equals -3, or +3, sorry, I keep getting mixed up. +3, let's just fix that right there. I apologize. +3, it doesn't work. It's undefined. And what happens, if we think of it, an illustration of this function machine is that once you throw in x equals +3, your function machine starts, making sparks and sputtering and spitting out smoke. So I'll draw some smoke coming out here, and maybe some smoke coming out here and over here, and out the bottom is like a little exhaust thing too. Your function machine breaks, essentially. And so if we think back, this means that f of x cannot accept an input of x equals 3. And so an example of this in real life, this would be like if you've gone to the store and you see the sign in the back that says we don't accept bills over $20, excuse me. So the function machine, or the relation machine, would be the cashier, and you can input into the cashier. Well, you can input a credit card, or you could give them you could give them $1 bill, a $5 bill, a $10 bill. You could give them coins, but you can't, and you can give them a 20, but you can't give them a $50 or a $100 bill. That'd be an example of this. And so what inputs can this function accept? Again, this is the exact same question, is what is the domain of f of x? So these two questions are actually exactly the same. Okay. So here's the thing. What caused this problem? What caused the problem? Well, the cause of this problem right here is this bit, right? The divide by 0 piece. What caused the problem was dividing by 0. And so the question is, in a fraction, what makes that happen is what makes the denominator equal to 0. What makes the denominator equals 0? In this case, it was only that x equals 3. So the denominator in this case is x equals 3. So what makes x minus 3? What makes x minus 3 equal to 0 is if x equals 3. But if x is anything else, anything at all, that denominator is not going to equal 3. For example, if x equals, let's say 7, then, well, this is totally fine, because I'll have f of 7 is equal to 6 divided by 7 minus 3. And that's just 6 over 4, which is 1.5. That's totally fine. It might be a funky decimal sometimes, like if I had plugged in a different number, this decimal might be kind of messy, but it still is a number, and so it's totally fine. And so another way to sometimes answer this question is, well, sorry, let's take it back. So the only x value that this function does not like is this x equals 3. So this would mean, because it cannot accept this input, this would say that x equals 3 is not in the domain. And the reason I bring this up is because sometimes it's easier to answer the question instead of like, what is this? It's another way to answer that question is, what is it not? And so what inputs can the function accept? So slash, what is the domain of f? Because it's the exact same question. The domain is any x value or any number except 3, or x equals 3. And this would be totally fine. Or you could say any real number except equals 3. Another way to write this is to just say what the domain is not. So again, x cannot equal 3, and you'll just draw that by drawing equal sign with a line through it. That's really messy. Let me fix that. By saying x cannot be 3. Either of these is an acceptable answer for this question. What is the domain of f? So this is saying this is what x values work. This bottom one down here at the red arrow, that's basically saying what x values cannot work. But that's the exact same question. Okay? It's like saying, who's the teacher? Well, Mr. Chang's the teacher. Or you could say, who is not the teacher? You know, all these people sitting in the desks are not the teacher. And that kind of answers the question the same way. Okay? So usually when I'm asking, hey, what's the domain of this function based on the equation? The easier way to answer that is usually what is not in the domain. One particular thing to look for is what makes you divide by 0, like in this case. There's actually another example of, or another instance of something to look for, and that we actually have seen it in this class already. But when we come back to class together, I'm going to ask you about that. So I'm not going to spoil it here, but I do want you to think about it. So thinking question right here. Question. What other, how to say? So we know that dividing by 0 causes problems in your function machine. What? I'll say it like so. What else can cause problems in a function machine? Okay, dividing by 0 is 1, and there's one more that we have seen before. Alrighty, thanks for watching, folks. I'll catch you in the next video.